Assalamu alaikum friends. Today we are going to study magnetization and demagnetization. There are two methods used for demagnetizing a steel bar. Stroking. In this method, magnetism is induced in a steel bar by using the magnetic field of a permanent magnet. The steel bar can be stroked into two ways: single touch method and double touch method. Single touch method. A steel bar is placed on a horizontal surface. It is stroked from one end to the other several times in the same direction using the same pole, say north pole of the permanent magnet. Every time the magnet is lifted up sufficiently high on reaching the other end of the bar. Double touch method. In this method, stroking is done from the center of the steel bar onwards with the unlike poles of two permanent magnets. It's at the same time. This method is more efficient than the first one. In both the cases, the pole produced at the ends of magnetized steel bar after stroking are the opposite polarity to that of stroking pole, making a magnet using solenoid. In this method, a steel bar to be magnetized is placed inside a solenoid long coil of wire. As shown, the solenoid should have several hundred turns of insulated copper wire. When direct current is passed through the solenoid, the steel bar becomes a magnet. The polarity of magnetized steel bar is found by applying right hand grip rule, which is stated as grip the solenoid with the right hand so that the fingers are curled along the direction of current positive to the negative terminal of the battery in the solenoid, then the thumb points to the north pole of the bar magnet. Demagnetization of magnets. Heating. Thermal vibrations tend to disturb the order of two main. Therefore, if we heat a magnet strongly, the magnet loses its magnetism very quickly. Hammering. If we beat a magnet, the vanes lose their alignment and the magnet is demagnetized. It is also called hammering. Alternating current. When an alternating current AC is flowing through a long solenoid, the magnet moved out slowly from inside the solenoid is demagnetized. Application of magnets in recording technology. Electromagnets have widely used in recording technology of sound, video, and data in the form of electrical signals through magnetization of a magnetic material. Most common magnetic recording mediums are magnetic tapes, and disc recorders are used not only to reproduce audio and video signals but also to store computer data. These materials are usually coated with iron oxide. Some other recording mediums are magnetic drums, ferrite cores, and magnetic bubble memory. Magnetic tape recording. Induced magnetism is used in process of magnetic tape recording. Recording and playing head is a coil of wire wrapped around an iron core. The iron core has a horseshoe shaped with a narrow gap in between its two ends. Audio and video tapes are synthetic tapes coated with a layer of ferromagnetic material. Sound or pitches is converted into electric form as varying current. These currents are sent to the head that become an electromagnet with the north pole at one end and south pole on the other end. The magnetic field lines pass through the iron core and cross the gap. Some of the field lines in the gap curved outward. As shown, the curved part of the magnetic field is called a Fringle field, penetrates magnetic coating on a moving tape and induces magnetism in the coating. This induced magnetism is retained when the tape leaves the vicinity of the recording head. The reverse process changes the varying induced magnetism into varying current that onward is converted into sound or picture. Hard disk recording. Hard disks are circular flat plates made of aluminium, glass, or plastic and coated on both sides with iron oxide. Hard disks can store terabytes of information. A magnetic head is a small electromagnet which writes a binary digit 1 or 0 by magnetizing tiny spots of the spinning disk in different directions and reads digit by detecting the magnetization direction of spots. The term hard disk is also used to refer the whole of a computer's internal data storage. Magnetic disk devices have an advantage over tape recorders. A disk unit has the ability to read or write a recording instantly, while locating a desired information on tape may take many minutes. Electronic devices can be protected from strong magnetic effects by enclosing them in the boxes made of soft iron. We will describe in detail in the next section. Soft iron as magnetic shield. Soft iron has magnetic permeability. The permeability is the ability of a material to allow the magnetic flux or lines of force through it when the material is placed inside a magnetic field. When a piece of soft iron is put into a magnetic field, it generates a magnetic field due to magnetization.